Good afternoon, all, and welcome to today's webinar hosted by Numerical Analytics Instrument Private Limited. Thank you all for joining with us. Today's webinar will focus on the topic of calculus before calculus using TI technology. So once again, I welcome you. I am Hassan, Education Technology Consultant at Numerical Analytics. So let me first brief you about the company. Numerical Analytics is a leading provider of modern education technology, analytics, and business intelligence solution. Numerical analytics has been around over 12 years, working with many educational institutes and corporate organizations to implement educational technology and analytical solutions. Our head office is in New Delhi and our main branch is in Malaysia. We are the sole distributor of Texas Instruments, which include scientific calculators, graphing calculators, and financial calculators across India. Also, we deal in verniers, probes, and sensors, which are compatible with TI calculators. Along with all these, other division of our company is analytical technology, where we support the research analysts to avail the leading qualitative and quantitative research software across India. So our partners are Texas Instruments, eViews, NVivo, and TIPCO. As we are dealing with many IB and IGCSE schools across India, I have brought you some schools over here that are the users of Texas Instrument from a very long time, like Ahmedabad International School, American Embassy School of Bombay, Chennai, Delhi, all are the users of Texas Instrument. Group of Indus International School of Hyderabad, Pune, Bangalore, all are the users of Texas Instrument. Kodaikanal School, the Oberoi, the Heritage, Navrachna, Stonehill, and many more, all are the users of Texas Instrument. So let's begin with our today's webinar. Today we have two of our T-Cube trainers, Mr. Paul Raj and Mr. Lon Lancaster, who will be sharing their valuable insight with us today. So let's welcome our first speaker, Mr. Paul Raj from Cathedral and John Convent School, Mumbai. He is currently teaching IB Mathematics, Advanced Placement Calculus, and IGCSE International Math. He has a master degree in mathematics from Mumbai University and is currently pursuing a course on mathematical mindsets from Stanford University. He has taught at some of the most reputed schools in India like Woodstock School, Kodaikanal International School. He is having 17 years of experience and he's very passionate about the technology and has used TI product and is familiar with TI ecosystem since 1997. So he's also an avid photographer and he's loved to travel in search of the perfect moment. So over to you, John. Let's start with the webinar.
Thank you so much, Hassan, for your kind words. You know, I see a lot of familiar names here in the participants. So I'm kind of a little, every time I see familiar people, I'm a little nervous whenever I'm about to present something. But thank you again, Ron. It's great to have this wonderful opportunity to be sharing at this webinar with Ron Lancaster, and once again to be on a webinar hosted by Numerical Analytics for Texas Instruments. And great to see people here coming to, spending an afternoon here. Those of you, all of us, it's a weekend and it's an afternoon, and to spare some time to come out and learn something just emphasizes that we are all, eager to learn, eager to find out new things. And across the globe, there we have Ron Lancaster sitting very early in the morning. For him, it's about probably 5:30, 6, something like that. I don't know, Ron. Was it what time is it there for you?
Sorry, John, I was muted. It is right now 6:30 in the morning.
Wow. So, friends, we have got an amazing people here. Like I said, on a Saturday afternoon, to sacrifice some time and come and be eager to learn. And at the same time, we've got Ron, who's there at 6:30 in the morning, sitting there to be able to share with us. This is fantastic. So I'm really looking forward to this time. And at the same time, I see Mr. Ranganathan there. who I have seen his name everywhere. It almost feels like I know him. I've never met him, but I see him everywhere, and he writes to me. So very, very, very happy to be here. I think the first thing that I want to share, because largely we all would like to hear from Ron. The first thing I'd like to share is from the website, and this is particularly for those who are not familiar with TI and who have not used TI instruments before. This is education.ti.com, and when you go to this website, yeah, there are several tabs, as you can see, but tabs to download the trial software. But what I want to highlight is this tab which talks about the activities. And when you go on the activities, and under activities, when you go to Math Inspired, and it'll load, and once it loads you can see all activities segregated into different groups: algebra 1, geometry, algebra 2, pre-calculus, calculus. And since you're talking about calculus before calculus, so let's look at something before calculus, something like algebra 2, and you hit that tab and you can see a number of different strands there. So if you hit something, let's say system of linear equations, there are lots of activities presented there. All that you got to do is that you got to download this, go to this option, it says download, and when you download, you will see, you'll be given 3 files. A TNS file, which is a file that works on the TI Inspire handheld as well as on the software. And then you'll also see, you'll also get a student handout and a teacher's handout. So that's pretty good. That's pretty good, because you can just go and search for, a topic that you're interested in, perhaps maybe it's something to do with inequalities. And here's the key thing. All of these activities are exploratory nature. They have this emphasis on investigation, on inquiry, and something that most international schools in India right now are waking up to. Everyone is saying, hey, this is the approach that we want to go ahead with. And because largely in a national curriculum, what's driven by is like, something's given, we have a model problem and we just have to do it. But now there is a sudden need for activities and inquiry and investigation. It really helps when we have such wealth of resources available to us. This should not take away from the fact that we should also create our own, but there's always a good thing to know that there are resources available in statistics. If you go to statistics, fantastic resources available. I'll show you some of them, what it looks like. So I'm going to quit sharing from here now, and I'm going to quickly jump to my Adobe. And this is what one of those activities looks like. And for those of you who have been on webinars before, you'll probably have seen this thing before. That is why I said I'm always a little nervous when I see something. This is just to let you know what you will get. Okay, so as you can see, this is a teacher handout, as it says, a teacher notes on the right hand side. And the objectives of that lesson, the vocabulary involved, the math vocabulary involved, what the lesson is about, and all the tips that will guide that investigation. And so the student handout will be very similar. This is the student handout. This is student copy, and it will be, just like a guided investigation. I strongly recommend those who have not tried out the TI, at least to go on the website first. At least look at these PDF files, and just look at how these activities are laid out. For those of you teaching IGCSE, that paper 6 in IGCSE is about investigation and modeling. And you will see that many of these questions are laid out in that same style, breaking it down. So you can pick out, something from maybe that applies to IGCSE and, allow for that. And maybe using these ideas, you can incorporate it into your own lessons. Maybe it's with TI, maybe it's with something else. But, since we are on the TI platform today, let's just stick to TI. So this is one example, and the reason I brought this example is because I thought I'll let you know what the resources are available. Resources which promote inquiry, resources which promote investigation. And so these are the handouts that you will get when you download, and what that software looks like on your TI handheld. Let me jump quickly to my TI software. This is not that. This is the one that we're talking. This is the crossing the asymptote. So this is what the students will see, and you will see if you have a TI calculator, a TI software. Here's the cool thing about the TI calculator, by the way. Nobody actually mentions this. When you buy a TI calculator, you get the software. You get the software, the paid version for the software. So you can go on the website and download a trial version. I think it's about 30 days or something like that. Is it 90 days, Swati, or is it 90 days? Not sure. But even if it's 30 days, it's a good time to try it out. But when you buy the handheld, you will get the software also, the key for the software, which then tells me that it's almost like, getting two calculators for the same price, for one of the price of one calculator. And there are ways to use both of them. In fact, in my experience, I've learned that you should use both of them. You should use both of them. You should also get your students to use both the software as well as the handheld. The software can be used in class when you are, conducting activities such as these. This particular activity is something that you can use in your IB year 11. Math analysis and approaches. I gave the students recently because we were talking about polynomials, and when you're teaching about asymptotes, the idea is either you can just tell them that, hey, you know what, the teacher's use is 90 days and the students can get to use it for 30 days. Yeah, that's great. Thank you, Mrs. Naik. So the teachers can download the software. The teacher's version is a 90-day trial version, and the students can get a trial version for 30 days. And although it's called a trial version, it's a fully complete software. Okay, so it's not like one of those softwares which we download as a trial, and some of the features are, there's a tab on some of the features. It's not like that. You can actually go through the whole, all the features, explore all the features, and crossing the asymptote is one such activity which you can allow the students to explore and find out, what are the conditions when a graph will cross the horizontal asymptote, because we're only taught, allowing the students to come up with a conjuncture, so this is on the software when they can keep doing these this kind of investigation, and they can go back and they can make notes about it on their handouts, which I showed you a little while ago. Here we go. That's the student handout, and the teacher tips are already given, along with what kind of questions you can ask them, how to go about it. So there's a tech tip given that if the student is unsure whether a graph is given, whether a graph of a given rational function crosses its horizontal, suggest that they zoom in. See, a tip given to the teacher. So I think it's pretty helpful to have such resources at hand, and that's, as you saw on that website, it's an ocean almost. There's a wealth of resources for every level also. For middle school level, so that means something which we can use even for 8th standard, and even leading up to 9th standard. IGCC classes, I've used it, and in my 11 and 12 I use it very often. My students have started becoming more friendly with the TI Inspire, to the point that I have now started bringing my grade 10 students, IGCC grade 10 students, to my grade 9 class, and we have an inter-class collaboration. So the students from grade 10, they will come and they will do some activities with the grade 9 class, and it's fun because students love learning from each other. It also, of course, helps them to socialize and get to know their seniors. So it's a fun way to use these kind of activities, and go on with that. One of my favorite features is what I'm going to talk about, and and then we're all eager to hear and learn from Ron today. So I'm just going to highlight one feature which I think is pretty much unique to the TI platform. All right, and I say it as much confidence because I have students in my classroom who use both the Casio and the TI, and especially when they're doing their IAs or they're preparing to their IAs, where we want to give them experiences of the toolkit for those of you who are teaching them math analysis and approaches, as well as the applications and interpretation course in the IB. You know that the toolkit is something that is a required part of the curriculum now. As much as possible, we want to give them experiences of investigation and helping them decide. And I think that's powerful, helping the students to decide what to do next. And I think many of these activities are tailored for the student to make the decisions. So anyway, enough said about the software and the website, so you guys can go and take a look at that website. Hassan, in his introduction of the TI handheld, mentioned about the IB recommendation, and this is the IB document, the latest document, 2019, and you can see that in the recommended calculators. This came out, I think, in September or October 2019, and you can see very clearly that the TI Inspire CX2 CAS. The CX2 was released only in 2019, by the way. So the CAS model is a recommended calculator. Many times I hear teachers, and because teachers say it, students say it. So I think it comes from teachers especially, who say that, the CAS is going to be locked. The CAS is going to be locked in the exam, the press to test. And by the way, this document is released by the IB, and you can see that towards the end of the document, it gives you the syntax of and what's going to be locked. So this particular page gives you all the hints of what gets locked off during the exam. And sure enough, the CAS gets locked. But I have heard it said by teachers, and because teachers say it in class, I think students catch up from there, that because the CAS is locked, then why should we buy the CAS? If the IB thought of it that way, then why would they recommend? That would be my first response. If the IB was thinking of it that way, because I think when teachers are saying that CAS is going to be locked during the exam, they are thinking of the calculator as only for the exam day. Only for the exam day usage. And my encouragement, and I think that's the reason even the IB recommends, my encouragement is that do not use or think of any piece of technology as only for the exam day. I think far too often in our national curriculum, we have emphasized all our classroom teaching, all our classroom work for the exam. So even then the students catch it, and then that's why they ask questions. Is this going to be graded? Is this going to be in the exam? It's not as much as learning. It's not as much as coming back a day and thinking, okay, what did I learn today? What did I gain today? What did I see today? How do I feel about this new thing that I saw today? Those kind of reflective moments are not there. So anyway, this is something that I just thought I'd add up about CAS. So what do I intend to do today with the little time that I have left? I am going to quickly run through one presentation I had prepared, and those of you who've seen this before, please forgive me. I didn't expect to see the same names again, but anyway, I love this feature called data capture. Okay, and I've used it in different contexts, and you heard one of the teachers, Harmeet, also another good friend of mine. I don't know whether he's here because I saw Ron's message about Harmeet, so I don't know whether Harmeet is around. But he spoke about data capture, and I think this is something I chose to talk about because this for me is definitely one of the highlights of this calculator. Okay, and while this is not an activity as such, this is a feature that any teacher can learn and then build their activities using data capture. All right, so I have on this slide something about why, why data capture. Like I said, it builds dynamic visualization. All right, on your handheld, the students, if they learn how to go about data capture, how to set up a data capture activity, then they can use it, whether they are an IB student, whether they are an IGC student, whoever, regardless of the curriculum. And the students can use it in their own presentations. You as a teacher can use it in your presentations. When you are trying to, create an investigation in a class, to keep it dynamic, to keep it interactive, you can use this feature called data capture. And students, when they are writing their math IA, when they're exploring something to do math in their math IAs, they can use this particular feature called data capture to make the presentations more interactive, sort of like a simulation. You can simulate rather than just presenting the final graph or the final output. Okay, so what exactly is a data capture? This is the kind of workflow that I have come up with There might be a shorter way, there might be a faster way, there might be a more efficient way. Please feel free to share if you have used this feature before. But I thought the first thing that I do is that after I've identified what I want to do, the first thing I do is that I create the object on the graphs page or the geometry page of the TI Inspire. So the first thing I do is I create the object, then I identify the variables involved, and then I move on. So let me just go step by step with what I'm talking about. Okay, so I will go to my Inspire, and I'm going to add. I was going to show a couple of other things, but if there's time at the end of our then I'll come to that. All right. So for now, I'm just going to go and quickly show you a little glimpse of this data capture. All right. So I'm just going to enter a circle because I'm going to enter the equation of a unit circle. All right. So x square plus y square equals 1. And since Mrs. Nayak is here, she will remember that when we were doing this earlier on, there was a problem that we encountered about the scale. But Mrs. Nayak, I found a way to go around it. Watch Mrs. Nayak, okay? So we have the equation of the circle. Instead of controlling the x and y limits, I just pull this thing out, okay? And it still remains as a circle. And this separation out here, that one, if I double click and make it 1, because it's a unit circle, this one, if I click it and make it 1, and then the resolution remains as it is. I think the last time we were doing it, Mrs. Naik, you recall we had a problem? So, yeah, I just found this an easier way or a solution just to maintain that aspect ratio and still have a unit circle. All right, so we were drawing the object, okay, and the idea if this is a lesson, let's say, when you're trying to help students investigate trigonometric functions and the graphs of trigonometric functions, using a unit circle, this is how I would go about setting up an investigation. So there's a circle that we draw, and then we want a point that moves along the circle. So there's an option called geometry, and you can pull out a point on the circle rather than just a point on the circle. So when you click that, you can have a point on the circle, and immediately you can see the coordinates of the point. And this is real fun because you can move the point around anywhere, and as you can see, the x coordinate and the y coordinate of the point move accordingly. All right, now we want the angle that it makes to the x-axis, so we'll create another point here. So I'll just go about it quickly. So I'm going to make that point right there. Cool. And we'll also keep this point here. The good thing about this software is that they label, but then if you don't want that point, you want this point, but if I don't want that origin, I can just right click there and I just say hide it away. I can just right click on this point also and just hide it away. And now I just want to measure the angle between them. So let me first create that angle by joining those points using segments. So again, go back to geometry and join those 2 points, and there you go. And from here to here we go. And if some of us like colors, then you can even color it, and you can create the angle in a nice color, a different color that stands out. So because it's the same angle, both the segments will try and create the same color. There you go. Now we got that, and we can see that the point is still moving. Let's create the angle and let's measure that angle now, what it creates. So geometry, this time not shapes or points. This time we go into measurement, and we say we want to measure the angle. And the angle, and by the way, whenever you go to that, can you see the small left-hand corner? That gives you the hint. So even when you're trying to construct something like this, it's pretty interesting how it gives you the hint. And there, the moment you've created the angle, it gives you the angle in radians. And you can see the calculator set to radians. So if I just click on that, it'll give me the degrees. So let's say you're working with the IGCSE students, you can, quickly do a interesting graphic like this and create the angle. And you can see now the angle and the point the angle changes as the point moves, or vice versa. As the point moves, the angle also changes, or as the angle changes, the point also moves along the circle. All right. Now, what's the point of all this? Why did we set it up? This was the first step. First identify and draw. The second thing is, now this is just one point. We'd like to see how or what happens to the angle or what happens to the x-axis as it moves along, x-coordinate of the point as it moves along. In order to do that, what I do is that this point I can now treat it or make it or force it to behave like a variable. So here's the trick. I just go on that one point, and let's say we want to study the cosine or the sine graph. Let's do the sine graph. So the sine we know is the y-coordinate of the point. So let's go to the y-coordinate of that point and right-click. I say store the y-coordinate, and let's call it yc because it's y-coordinate, and hit enter. And suddenly it becomes bold because now it's no longer just a point. So let's understand how it's done. You go hover around that point, right-click on that point, store it as a variable xc. So x coordinate and y coordinate are now bold. That means they're now a variable. Likewise, we'll go to this angle, right click and say store that, and let's just call it th for theta. So they're all now variables. What we do now is that we want to collect this variable or collect all the data, as it moves along. We want to collect it on a spreadsheet. So what we do is that we insert another page, another document, and this time we want to put a listen spreadsheet page, and we want to do a sine graph, let's say. So let's just call this y coord, and let's just call this angle. All right. Oh yeah, we can't call this way because angle is something. Ang, let's call it Ang, and so we've created this spreadsheet page to record or to capture all the data. And the way we capture the data is we go on this command, and here we go to menu, data capture, and we say automatic. And when we say that, we say, okay, what is it trying to capture? So we just enter the value. It's yc coming from there, from what we've set up. And we hit enter. This value that you can see is the value of the y-coordinate that was here. Here it is set to, I think, 3SF, so you can see only 3 significant figures, whereas here you can see all other digits. Likewise, the angle, if you want to capture, do the same thing. Go to menu, data capture, and this time we are capturing the angle, which we represented as TH there, and there you got the angle there. So what's going to happen is that as this point moves along the circle, as you move the point, and as the angle also keeps changing, guess what's happened here? All the data points are captured. And there's a lot of fun things we can do with this data that you've captured. There's a lot of fun things that we can do with this data that's captured. This is called data capture. Now what you do with it is the sky's the limit. You can draw the scatter plot, and see what the graph is, because now we have x and y. We captured all the y coordinates for the x values, and you know that if you were to do the graph, if you were to plot the graph of y against the theta or the angle, you should get the graph of sine. So let's quickly see that. So I'll just quickly insert another graphs page, and this time we will have a parametric graph. So let's just graph entry edit. So we make it a parametric, and the two values we want is what was it called? It was y coord, I believe. On the x-axis it was called A and G, and the y coordinates are
XC.
The y coord. I'm trying to get the
YC.
y. Good point. You know what? We need to label it what is mentioned on this, where the data is coming from. So although on here we've called it XC YC, but the scatter plot is going to be what's labeled here. So it's going to capture from here. So once again, let me just clear the data that I already have captured. Okay, so I've cleared the data. As you can see, the data is all clear, and we are set now. And so let's just move this maybe to 0, or yeah, because the angle is not going to be there. There you can have that this way, and I can even zoom to zoom data. So it's all set and ready, okay? And let's just capture it and see what's going to happen. So one more time, the data is going to be captured, but this time, not only is the data captured on our list and spreadsheet, but when you look at the graph, oops, it didn't capture here. Why? Let me just go and see that again. No. Epic failure. What just happened? No, it's not zoom trig, is it? Did it? One sec. Did I? Angle is on the x-axis, yes. Does it have to something to do with this t-step?
John, I think you have to change degree to radian, as Shraddha ma'am also pointed it. Yeah. Now zoom fit.
Zoom data? Or zoom fit? Zoom data. Still not happening. Because the data here is captured in... Okay, they all are in radians now.
John Paul, sir, the angle should be on the x-axis.
Isn't it?
Yes, yes. Angle should be on the x-axis.
So it is there on the x now.
But when you see on the list and spreadsheet page,
But that's alright, because it's coming from there now.
oh yeah.
This is interesting.
Can you please click on var key once near the x1 coordinate? Delete this and click on var key.
One second.
Yeah. Oh.
I need a equal to sign.
Mr. John, can you go to menu?
One sec. Let me just put this thing quickly.
Use the scatter plot. I think you have not
Yeah.
used the scatter plot.
Sorry, it's into parametric. You're right. Thank you for bringing it. It should be scatter plot, not the parametric. Thank you. That's the difference. Thank you, Hassan. It should be scatter plot, not parametric. Yeah. So scatter plot. That's where it was. XC. Thank you. Yeah. Here we are. So x is our angle, and y is our y chord. And now we should see it, and we can go back to no, it should still be there, and let me see whether I can zoom in with the data. Yep, but why is it giving me this one? Let me try this again. And if I have it on radians, all of them are radians, okay. Yeah, I think we should get it now. So one more circle so that we get all the data, as much data as possible. This part is alright. This part we're getting it up here. Just spread it a little bit, because my x is, yeah. I'm not sure why we're getting this thing on this. I'm not sure why we're getting this thing here like this. That's not quite what a sine curve should look like. Yeah, this is not what a sine curve should look like. I don't know why we're getting this thing, because this is just looking like a reflection. Anyway, I'll figure this thing out. I don't know what's happening. My time is also running out. I will look at this and I'll get back to you guys. X-axis is angle, that's right. Y-axis is the y coordinate, and that is also right. It should give me the sign, and I think this was the error. I think it has to be a scatter plot and not a parametric graph. But I'll get back to you guys on this. Here's the thing which I wanted to just if you can quickly recap. The idea of data capture is what you have seen right now, whatever diagram you have created. That's the first thing. And any data or any interactivity, the idea is that anything that you can create with interactivity where the students can then explore. Okay, this is, of course, I had to do it much faster, but in your class, of course, when you do it with your students, allow them to see. And of course, if you go into these kind of issues of, that's a great thing to also learn. Why isn't it coming on a parametric graph? And if the students are of grade 11 or 12, they can analyze, should it be a parametric, should it be a scatter plot? Allow them to decide. Those are the things that I was talking about. Allow students to make the decision. What's the, like even earlier we saw, which is the data that we're capturing. Here we labeled it at y coord, here we labeled it at angle, but here we labeled it at th. Those are the things that you can ask them to make the decisions rather than you giving them the decisions. Okay, and then while we have something going on, maybe towards the end of the this webinar, I would have figured out what's going on in this graph. So just give me some time and I'll figure this thing out, but we should be able to do this. But anyway, thank you so much for listening to me, because we are all really eager to hear Ron Lancaster. So as I hand over the share options to Mr. Ron, let me quickly introduce Ron to you all. Okay, Ron, first of all, I heard about Ron through a webinar that I saw, and here's the thing that was my own personal experience of watching him at that webinar. The first thing that I found about Ron was that anything that he did in that webinar was about bringing everyday examples to the classroom. And from the webinar that I saw, it was about newspaper articles, how he brought newspaper articles into the classroom, and he made students in the workshop he was talking to teachers, of course, but how we can use everyday things that happen in our society and how to make students aware and see through the mathematical lens. I quickly used it in my class. I wrote to him, and I was surprised that he actually wrote back to me. Okay, this was about last September that I wrote to him when I saw that webinar. So for me, it is such an honor, and I would say it's a real privilege for all of us to be able to listen to such a great man. Ron is an associate professor at the university, at the Ontario Institute of Studies in Education. He travels all over the world conducting workshops for teachers, and he's done hundreds of conferences. He's also a writer. He's a prolific author for the Mathematics Teacher. This is a magazine for mathematics teachers published by the NCTM, that National Council of Teachers in America, North America, I think. But his interests are that wherever he goes out, apparently, he doesn't go out without what he calls his math class, meaning, a mathematical perspective. Whatever he sees, he's always taking pictures with the camera. So he always goes with the camera, whether it's his phone or whatever. He uses that to take pictures of shapes that he observes, of patterns, of solids, of course, anywhere, shadows, numbers. In fact, in one of the in that webinar that I saw, when he introduced himself, he also had shown his number plate, a photograph of his number plate, which interestingly had something to do with was it pi or something? I don't quite remember. But some of the photographs that he has taken and he shares in his webinars are around a cafe called Pi Cafe. I've seen all those photographs, Ron, so I remember all those things that you shared. But more than anything, I think the reason I say he's such a distinguished guest that we have today. He's also the recipient of the 2015 Margaret Sinclair Memorial Award for Innovation and Excellence in Mathematics Education. So he's an amazing person to learn from. All of us teachers who are here, I think it is, on behalf of all of them, Ron, I would like to say that it is a privilege for us to be here, to listen to you. So welcome.
Thank you, John.
Welcome, and it's all yours.
Thank you, John. I'm attempting to start my video, my camera, and I'm blocked. So it looks like the host has to start to allow me to do this. So I'm still blocked.
Mr. Ron, I think you can start your video.
It says the host has stopped sharing my video.
Okay, now can you? Now can you make me host, Mr. Ron? Can you change the host?
Do you want me to stop sharing?
No, just change yourself from the hosting and give it to Jyoti Megara.
Okay. Sorry about this, but I'm not sure where you want me to do this from.
Go to participant list, Mr. John. Oh, Mr. Ron.
Okay.
And then click on Jyoti.
Okay.
And then make host.
Promote to panelist?
No, make host.
It doesn't say. It just says chat, promote to panelist, rename, remove, allow to talk.
Okay. Okay, continue, Mr. Ron. Continue.
Still can't start my video. Can you see my screen?
We can see your screen, sir.
Okay. But you can't see me.
Yeah, you can't see you.
Do you want to see me or should I just start?
I don't know, some setting problem is there. You can continue.
Okay. So good afternoon to all of you. Good morning from me. My name's Ron Lancaster. And as John was saying, I really enjoyed listening to John's presentation. I thought there was a real teachable moment. I work with the next generation of teachers. So I'm in a teacher's college, although, I've taught middle and high school for over 23 years. But I think one of the important things that was happening at the end with John is that, the problems that we're encountering as teachers, it would be easy for us to just attempt, to just carry on and not stop. But I think the beautiful thing is that John was open to, trying things and listening to others, and trying to, get feedback from other people. And I think that's really important in our classes, to get our students involved when, things happen, to ask them, what do you think I should do? So look, I started using a graphing calculator back in 1985. It was a Casio calculator, amazing invention. And then gradually, Texas Instruments introduced the TI-81. It was around 1980, 1990, 1991, somewhere in there. And at that point in time, it was kind of the death of the Casio machine. The TI-81 was very friendly to use. And it just, the sales of Casio just fell off with that. I have to say that today, the Casio machines are amazing. I went to a Prism conference, the Casio Prism, some years ago, and I was quite impressed with the device. So I think it's also a good device for those of you who use the Casio calculators. I'm not going to knock it because I think it's a great machine. However, it's always good for you to be aware of what other technology is out there. And I think one of the key advantages of the graphing calculators from Texas Instruments is what John was showing you. It's the website. Because you may not be aware, but Texas Instruments a number of years ago formed this association, this group of teachers. They're called T-Cubed Instructors, Teachers Teaching with Technology. I became one of them in 1994. And there's, 200-300 teachers who have been involved in the development of the products. So I've been down in Dallas a number of times when calculators are being developed. I saw the very early versions of the TNspire long before it was in the market and was providing some, ideas and, things that they could do with the machine. And that's something that's been particularly unique to Texas Instruments, is the involvement of teachers, with that. And that's one of the things that you get with the TI product, is this website that is just filled with all kinds of resources created by teachers. So that's one advantage of it. So today, what I'd like to do is to...
Mr. Ron, sorry to interrupt you. Now you can start your video also.
Oh, okay.
Yeah, now we can see you also.
Oh, fantastic. Oh, that's great. Okay. So anyway, John mentioned about my license plate. Can you see it in the lower right corner? Hello?
Yeah, sir. We are listening.
Okay. Can you see my license plate?
Yeah, sir.
Oh, great. So it is a calculus license plate, and it's DYDX. My email address has calculus in it. It's Ron2718, and that's because of E 2.718. So, so I have mathematics all over the place. And I know that you might not be able to see me very well here, but that's a picture of me. So that's what I currently look like. So what I'd like to do is an activity. I wish that you were with me right now so that we could do this activity together. But this is going to start off with no technology, and then I'm going to move into using technology. This isn't the way you always have to do it. There are some teachers that passionately believe that you have to start without technology and then you move to using technology. I don't think there's any law in the world that says you have to do it that way. So I think, it's good as teachers to try different ways. Sometimes you start with technology and then you move to not using technology. Sometimes you never use technology, and sometimes you use it all the time. So there's a variety of ways of doing it. But this is the problem that I want us to look at. This problem is normally done in a calculus course. But I want to make the point here that this problem can be done in other grades. You don't have to wait to the calculus for students to do this amazing problem. So you have this circular sheet of paper. We're going to cut a sector out of it, out of the circle, and we're going to tape the edges together and make a cone. And we're interested in the maximum value of the cone. So this was the description that you would have seen. So the materials. So I'll say more about this in a moment, but you're going to need some round sheets of paper. You'll need protractors, rulers, glue sticks, tape, just stuff in your classroom. I like to set up a makerspace where I just have all kinds of stuff in the room. And when I start an activity like this, I try not to tell students what to use. I have them go back and look at the stuff, and they can decide what to do. All over the world, we've been moving away from telling students what to do and, allowing students to choose the tool, to choose the method. So those are some of the resources. That's what the colored paper looks like. I'll tell you more about that in a moment. That's another option as well. I have to tell you that it's becoming harder for me to actually buy round paper at local stores near me. So I found a couple places that I can order the round paper from online. So I've been able to do that. I've been in India several times. I spoke at an experiential conference at the Heritage School a few years ago, and then I was there on another trip. And on both trips, I bought round paper. Whenever I see it, I buy it. So I actually came home from India on both trips with great big stacks of round paper that I bought in small shops in Delhi. I wish I could remember exactly where those shops were, but I was able to find them. So you may be thinking, I don't have any round paper, I can't buy it, I'm not going to do the activity. Well, come on. I mean, if you don't have the round paper, you don't have to chuck this activity. You can make the paper. So you can actually have your students, make the paper and do that. So there's no reason why you have to, not just stop. So I'm going to take a moment and I'm going to just switch over to a camera because I'd like to just show you a few things about this activity. So this is what the round paper looks like. Okay, this paper here is actually for a dinner party. And this is what you would set out on a table where you would set plates underneath of it. If you're going to if you have to make the paper yourself, you may get some sort of template. This actually came with the round paper, but if you don't have the round paper, you're not going to have this, so that's no good. So I'd suggest that you use a plate. You can just take a plate on a big sheet of paper and just trace around it and then cut it out. One of the things that I would suggest that you do with your students or have them figure this out is when you take a pen to trace around this, push really hard in the paper, and score it. And if you push really hard, you'll find that the piece of circular paper almost pops out because it's, been pushed in. So you probably won't even have to use a pair of scissors, to cut out the circle. So that's a really nice way. Oh, by the way, this is my favorite plate. This is a pie plate. And I use this for baking pies. So in this activity, what you're going to do is give each student an angle. So I usually start at 15 degrees, 30 degrees, 45 degrees, 60 degrees, and so on. So every student gets their own angle. So one student gets, this angle here. And so they're asked to take their circular sheet of paper. They're going to need to find the center in order to make their sector angle. Again, we're moving all over North America. As I said, we're moving away from telling students. So I would not tell students how to find the center of the circle. You can obviously do that by folding it twice. Let them figure it out. Have students work together in small groups and turn it over to them to figure out. But that's what one student would get, and they would cut this out. Again, if you press really hard with a pen, you can score it, and you'll actually be able to just pop this out. You really won't even need a pair of scissors. Another student might get this one, so it's a bigger angle, and another student gets this one with an even bigger angle. So it's very personalized. Every student gets a different angle that they have, and they make their sector. This is what it's going to look like. So they're going to cut out their piece of paper, and then you ask them to roll this up into a cone. I have to tell you that this is actually not easy. So again, I try to just let students figure this out. But if you take the paper and roll it up, with a pen, you can actually make this curved, and it'll be a lot easier to actually put this together and make your cone. And it's also a lot easier if you collaborate. So if you have another person holding the tape or the glue stick. The other thing that some of my students have done is they get to this stage and they realize that, oh, this is a bit tricky to make. It would have been nice if I had tabs, some sort of tab that I could put underneath. I could put glue on it, tuck it underneath, and then there's no tape on the outside. So sometimes they'll say, can I make another circular piece of paper? And so they'll do that. So, and now again, you could say, well, maybe, we should tell the students at the beginning to put in a tab. I don't think so. I think it's just, it's better to let them figure these things out. And if nobody's figuring it out, well, then at that point, you can provide some prompts, and tell them. But this is what it's going to look like at the end. So that's a cone. And it is the coolest thing when you have all of these cones. If you have a class of 35 students, 40 students, you can have all of these cones set up. And then, what I like to do with students is ask them, what do you notice about the cones? What are you wondering about? What questions do you have? And, the students will start to notice that some of the cones are really tall, other cones are short. Some cones have a really big base. Other cones have a small base. And so, they say, well, I'm wondering about the volume of these cones. And a question could be, I wonder if the volumes are all different. And if they're all different, I wonder if there is a cone that has the maximum volume, the biggest volume possible. And that's at the heart of this activity, overall. So that's how I'd suggest that you start, with some manipulatives here, have students make this. I think one of the problems for me over the years as a calculus teacher is when I used to use this problem in the calculus class, it was just a really routine question. Students set up an equation, they differentiated it, they made it equal to 0. They checked to see if it was a min or a max, they got the answer and they moved on. It was like 5 minutes. And they never got a chance to see the cones, to see a lot of things that are going on with this. It was just boom, it was done. So I think doing this before calculus is a really good idea because it gives students a chance to really experience the problem. And then when they get to the calculus, they can do it with the derivative. So let's go back to my computer and we'll take another peek at this. So I'll just get back to my PowerPoint file. So this is what it looks like initially. There's no algebra. Students are given different angles and they make their cones. And what I ask students to do is to find some things. Find the radius of their cone, find the height of the cone, and the volume of the cone. And again, I try and leave it up to the students to try to figure out how to do that. If they're having trouble, then I provide some prompts. If a student comes up to me and says, look, I don't know how to find the radius. I don't know how to find the height. I'm stuck. A nice thing to do is to say to students, did you ask somebody else? Did you ask 2 students? That's a good strategy in class because then you're not bombarded by 20 students coming up to you saying, I'm lost, I don't know what to do. Tell me what to do. So go ask somebody else. And if they still don't have an answer, come back and see me. That gives me a chance to move around the classroom and observe what the students are doing. So some students measure the radius and the height just with a ruler. I mean, that's one way that you could do this. And then you could calculate the volume. This activity is often referred to as a low floor, high ceiling. The low floor just means that everybody can enter into this problem. There is nothing that you're looking at right now that most or all students can't do. You take a piece of paper, you make the cone, you get the height, the radius of the cone, maybe even with a ruler, and you calculate the volume in doing it. So it's low floor, it's accessible, to this. But the really advantage of this is that students really understand what the problem is about. Because oftentimes when students simply read over a question, they have no idea what the question's about. These manipulatives really help them experience it. So, so again, that was the, what do you notice? What are you wondering about? So, what does your mathematical intuition tell you about the volumes? Will they all be the same? If not, which one will have the largest volume? That's the information that students work out. So they work that all out for their personal cone. And then I have students share this information. You can do this on your blackboard or on your whiteboards. So everybody comes up and they share it. Or you could have TI Inspire opened up. You could have a spreadsheet opened up and the students could come in and enter in all of that data. They put in. So you're aggregating all of the data from the class. You're getting everybody's volume, from each individual person. And then you make some graphs. So you graph the radius of the cone versus the central angle. Now keep in mind that the central angle, that's what I handed out. That is the independent variable. The radius of the cone is the dependent variable. And so they're making a graph of the radius. How did the radius change as I increase the central angle? And they make a graph of the height versus the central angle. The central angle goes on the x-axis, and they do the same thing for the volume. And there's no technology being used here. And again, I'm not suggesting that you always start this way with no technology, but this is, in this case, it's a nice way of starting. So they're getting these graphs. And at the end, who had the cone with the largest volume? This is the data. Now, when your students do this by hand, they are not going to get this kind of accuracy. I did this in Excel, or I did it in Inspire, but that's the data. So, and I like students to look at the data. You know, what do you notice? As the central angle goes up, what happens to the radius? What happens to the height? What happens to the volume? And you notice that the radius, it's going up. You can see that. And you can also see that the height is going up. But they're, you know, if you look at how they're going up, you know, the question is it linear or is it not linear? The volume certainly doesn't look linear. I mean, it would, you know, jumped up a little bit at the beginning and then it's really jumping up. But according to this data, it appears that the person who got 300 degrees for their sector angle, they have the biggest volume. And here's what the graphs look like. So this is really a nice way for you to start. If your students have seen linear functions before, so it's a reminder of that. But this is all done just with the data that you've collected. So the really nice thing at this stage is this activity really demands the use of technology. We're not just using the technology because we have it, you know, because we've got all this technology, so we better use it. The central question here is, can we do better? You know, is there a sector angle that in fact gives you a bigger volume? Well, you know, I don't want to make 300 cones. You know, I don't want to hand out to my students, you know, a sector angle of 1 degree, 2 degree, 3 degree, 4 degree. It's not a good strategy. So we really need to use some technology here. And this is where Inspire comes in. So you've got the handheld model. You've also got the software. I own both of these. I have the handheld device. I tend not to use it very much because I prefer the software, but the handheld unit is what your students would have. By the way, just full disclosure, I think it's important for you to know that I am not an employee of Texas Instruments. I don't own any stock in Texas Instruments, and I'm not even being paid for this workshop. I mean, the folks at Numerical Analytics, they never even asked me if I wanted to be paid for this. The only thing that I'm in debt to Numerical Analytics is a few years ago when I did a trip to India, they helped pay for my expenses. It was a trip where I wasn't paid for anything. They just helped cover my airfare. So full disclosure here, you know, I'm not benefiting from talking to you about the Inspire. You know, there's not money going in my pocket by trying to, you know, persuade you to use this. So let's start off and start to use some algebra here and some technology. So that angle that I was handing out, I'm going to call it x degrees. And the volume of the cone, I'm going to call it y. And an important thing to ask is, what is the domain of x? We did 15 degrees, 30 degrees, 45 degrees when I handed out the angles, but the domain could be more than that. Could it be negative 30 degrees? I don't think so. I don't know what that would mean. Could it be 5,000 degrees? No. So, you know, the domain is between 0 and 360 degrees. And then you express y as a function of x. Now, in my early years of teaching, this is how I worded the questions. And the problem with this is if a student cannot figure out how to express y as a function of x, they're stuck. They can't do anything else. So I gradually started to put in a question after part B, and I gave the students the function. I said, you may have had trouble in part B, so here it is. Now continue on. Now, they're not going to get any marks for part B because they weren't able to express it, but at least they can finish the question. At least they can keep going. So that's something, maybe you do this, but if you don't, it's something you may want to consider doing. It helps more students to be successful with this question, to do that. And you might even get some students that when they see the equation, they might be able to go back to part B and kind of work backwards and say, yeah, I think I can get this. And, for me, that's okay. I mean, what we want students to do is to be able to express y as a function of x. I don't care how they get there. So if that's how they get there, then great. And then in part C here, use technology to graph y versus x. And a good question is, the graph that you get using technology, how does it compare to what we did when we weren't using technology? So here goes. The development of this equation is a little bit tricky. You have to let the arc be A, and then it's all about just ratio and proportions. That's all that you end up using here. You just go through this ratio. A over 2 pi is x over 360. So you can get the radius in terms of x. The value of r is the radius of the cone. In this case here, I'm just letting the cone be 1 unit. By the way, a tip. The circular paper that maybe you make? Use big paper. Because if you don't, it's really tough to make these cones. So use a big sheet of paper. But for the mathematical analysis here, I'm just using 1 unit, for this. So here's the mathematics. The radius of the circle is x divided by 360. That's why you saw a linear line. That's why the relationship between r and x was linear, because it's just a very simple equation. The slope is 1 over 360. And then the height is just using the Pythagorean theorem. And so you get h equals the square root of 1 minus x over 360 quantity squared. And so there's the formula. And you can now enter that in to a graphing utility, like Inspire. And that's what you get. I'm not going to go through all the details of, all the keystrokes for entering this in. That would be a different story here. It turns out that when you use Inspire and do this, this is what the software looks like when you use Inspire. So in order to enter an equation in, I'm just going to press Command G, and it gives me an entry line here. It's similar on the handheld device, and so you can actually enter your equation in. And where you enter it in from, there are templates that you can use. There are symbols that you can use. So you can use all of these things to enter in your equation. And so it's pretty easy to do here when you enter all this in. And then there's all sorts of commands that you can use. You can change the window. So you can change your window settings when you're on the handheld device or in the software. You can also analyze graphs. So you can do a maximum as well, which is of interest to us here. So this is what the software looks like. And as I say, it's pretty easy to use. It's not a big deal, to use this. So that's what I was using to get these screenshots here. So that's what the graph looks like. A good question for students is, how does this graph compare to the graph that we got when we used the data that we collected by hand, for making measurements or calculations or however we did it? Is this consistent with what we had? If it's not, why is it not consistent? Where have we gone wrong? And in this case, it is consistent. I mean, this graph here looks pretty similar to what we had a moment ago. And there's the maximum. So we found that the person who had a 300-degree angle, they got the biggest volume. It turns out that Inspire tells us that it's actually roughly 294 degrees, is the angle that we get. So, so that's a really nice way of kind of going further than what we could have done by hand. We could not have got this result here doing it by hand. So I'd like to slow down here a little bit because it appears that the problem is over. The question was, which sector angle gives you the biggest volume? We now know, we have an approximate answer. We could get this even, a closer answer. We could have also looked at a table of values on the Inspire. So we could have a list editor. You'll see more of that in a moment. But so we could, we could say the problem is done. Well, it's not done. Because if you do this before calculus, it's really beautiful. What you could stop and do is just take a look at that formula. That formula is the product of two functions. It's x over 360 quantity squared. That's a parabola. And it's the square root of 1 minus x over 3 over 60 squared, which sort of looks like the equation of a circle. Gee, I wonder if it is a circle. More on that in a moment. But at the central thing here is that this is the product of two functions. So before the calculus, when you're teaching about the product of two functions, this is a perfect place where you could use this activity. It arises naturally to do this activity because it's a product of two functions. That's what the two functions look like. So why does the graph look like that? Why is this happening? This is a great question for students. This graph right here, the graph that you're looking at, the blue graph, if you look at it and go from left to right, you'll notice that F2 is very, very tiny at the beginning. F3 is very close to 1. When you do the product between those two things, F2 drags it down. You've got numbers very close to 0. But as you go from left to right, F2 starts to go up and F3 goes down. And in fact, near the end, F3 just drops like a rock and F2 starts to, in this case, F3 starts to dominate. It's the one that's very small. And in between, there's this harmony between the two of them. They're kind of both big. And that makes the graph go up and come back down. So, so this really helps students understand why the graph looks the way it does. It's the product of those two functions. Maybe you'll see it better if you look at it this way. So there's F2, there's F3, and F1 is the product. You can look in the first row. 0 times 1 is 0. That's why there's a 0 there. If you look at the column for F1 at the second entry, it's 0.000008. That came from the product of F2 and F3. And you'll see there that F2 is very small and F3 is close to 1. As you get further up with your angles, you start to notice that F1 is going back down because of how the numbers are changing. So I won't go into all the details here with you, but I think it's really important for students to see this. So spend some time having students do this analysis. Look at the two graphs, look at the data, and just keep your focus on the fact that F1 is F2 times F3. And you notice that at the end, F1 is now very, very small. And it's because in this case, F2 is small. It's dragging it back down. So that's why the graph looks the way it does. Something you might want to do is actually do a transformation of this so that you can see this in a different way. So I've replaced every x divided by 360 by x. That's just a shrink. It's just a dilation. And when you do that, you end up with a third pi x squared times the square root of 1 minus x squared. And it now has a domain between 0 and 1. So you could do this if you'd like as well. You know, this is about transforming a function. And now the graphs, you know, they're perhaps a little bit easier to look at. You don't have all the 360s there. And again, you can look at the product between these. By the way, you'll notice that there's a little extra thing here. One of my pet peeves when people use Desmos or Casio or Inspire or whatever, when they plot functions, they just plot them. They don't worry about the domain. This image right here is actually wrong. These graphs, the value of x has a domain. It's either between 0 and 360 degrees if you're using the original version, or it's between 0 and 1. So you need to add in a restriction, you know, to do that. And Inspire has a way of doing this using a piecewise command. So that's what the graphs really look like, you know, to do that. So if I lost you a little bit with this extra piece where I transformed these equations, don't worry about it. You know, you can just go back and work with the original equations. But the point is that what you're really dealing with is a function that is the product between two other functions. So we need to stop for a moment and let's think about where else in the curriculum does this come up? So where else do you have the product of two functions before calculus? So if you were with me right now, if we were all in the same room, I would stop and I'd have all of you pair up with somebody, do a think, pair, share, and I'd have you think about this. Where else does this come up? When I do this with teachers, it's very interesting. Usually there's silence. Oftentimes many teachers think, gee, I'm not sure. I don't know where else this comes up. Well, it turns out this comes up when you teach quadratics. Well, it depends on how you teach quadratics. But one thing you could do is, you know, oftentimes teachers start quadratics. They come in, they tell their students, we're starting a new chapter. It's quadratics, get out your notes. They put up y equals x squared. They have a student maybe make a table of values, you know, make a graph, all of that, and then do the transformations of the parabola and all of that. So that might be how you do this. What you might want to do, maybe you do this. If you don't, here's an idea. Come in and say to your students, you know, you've been working with linear functions. So you know everything about linear functions. You've taken linear functions, you've added them. You know, you've taken 2x plus 1, y equals 2x plus 1. You've taken y equals 3x minus 17. You've learned how to add these together. You've learned how to subtract them. You've learned how to make graphs of these things. You've done all of these things. So this year, what you're going to learn to do is to multiply them together. So that's what we're going to do. So you could have them get some technology. So in this case, you actually start with the technology. You begin with that. And so they make a graph and they take a look at what they get to do this. And what I like to tell students is that high school math is really just a repeat of elementary school. Well, not quite. But, you know, when kids learn about numbers, they learn how to add numbers. They learn how to multiply them together, add them together, subtract them together, and divide them. Well, that's what you do with functions. You first of all learn about linear functions. Then you learn how to multiply functions together. And then you learn about and you add them. Then you learn how to multiply them together. And eventually, when you do rational functions, you're dividing them. So it's really just a repeat of what they've already seen. Anyway, this is an interesting thing for you to think about. So, you can go around the classroom, give every student a different pair of linear functions, and have them multiply those together and get a graph. And everybody can put their graph up in the board, or you can have you can have everybody walk around and look at everyone's graphs, and they're all going to notice that it's this curve thing. Sometimes it's upside down, sometimes it's wide, sometimes it's narrow. It depends on what you've started with. And why does the graph look like this? And really, if you do a table of values, it's because there's times where the original two linear functions, the y coordinates of those linear functions, are both negative. And when you multiply them together, you get a positive answer. And there's times where one y coordinate is positive and one is negative. And so you get a negative one. Maybe just as an aside, I'll just show you a quick thing here. This is a file that I created with the Geometry Sketchpad. This is a little bit trickier to do with Inspire or with Casio or with anything. But take a look at this. This is a very visual demonstration of what's happening. The two purples, they're negative, and the graph that you're looking at that's moving is red. And it's red because a negative times a negative is a positive. And that's why it's changing this way. And so right now, one is negative, one's positive, and so now it's negative, and it's all color-coded. This may be going by you a little bit quickly here, but it's a real visual way for students to see why the graph looks the way it does. Anyway, that's something that you should give some thought to. I'll just come back to my PowerPoint. So that's another place where the product of two functions comes out. And if you do that when you're teaching quadratics, when you do this cone problem where the two functions are more complicated, it's not the first time that they've seen this concept. They saw it before. And really, when you teach cubics and quartics, they're just the product of linear functions as well. X minus 1 times 2x minus 3 times x minus 5. And you get a cubic. Why does it look that way? You can do the same thing that we're doing here. So I want to end just with a second problem. So I hope you're okay on the first problem. So it began with no technology, actually making the cones, having that whole family of cones there, having students find the radius and the height of their cones, perhaps by measuring, but at some point using the Pythagorean theorem and the ratios and proportions in the circle. So definitely having that, and then getting the graphs, and then turning to technology. So here's a second problem. This is actually a really beautiful problem. Remember how this is what the cone was made from? But there was this piece of paper here. So, this one just got tossed to the side. Well, what would happen if we use both of these? Make a cone out of this. Make a cone out of this. This is every student. So they can go back to this piece of paper, make two cones. By the way, one of the things they'll discover is that the cone from this paper was actually already made. Somebody else made it. Because, if one person gets 30 degrees, there's another student in your class who got 330 degrees. This one here. So that's actually kind of cool, when that happens. But students make a second cone. So now they have two cones. And now they want to look at the combined volume. So when is the combined volume of these two cones a maximum? So take a moment and I want you to think, what angle do you think produces the maximum volume? So you're taking a circular sheet of paper, you're cutting out a sector, you're using both these pieces of paper to make two cones. Which angle, which sector angle, makes the volume, the combined volume, the biggest? If you were with me right now, I would want all of you to write down on a piece of paper what angle you think it is, and I'd have you hold it up. And I think some of you right now are probably thinking, come on, Ron, the answer is obvious. It's 180 degrees. I mean, why should this cone be more important than this one? You know, there's some symmetry. So some of you may be thinking that this is actually kind of a dumb problem because it's 180 degrees. The answer is obvious. Well, it turns out you're right. So it is obvious. So there's no point in doing this problem. Actually, there is a point, because at least you can try to get your students to come to the obvious conclusion that it is 180 degrees. That's the angle that produces, that gives you a maximum combined volume. It's still a good thing for students to work through. But let's see what happens if we use some algebra, because it'd be interesting just to see what do we get in this case. So here's the algebra. So that's our original equation. So that's the first one we had. That's the equation for the second cone. So this is x right here. So that's our angle x, and the reflex angle here is 360 degrees minus x. So we want the combined volume. So we're going to graph the sum of these two functions. So this is another place where you could use this before calculus. So when you're teaching the sum of two functions, this is a perfect place to use this. So there's just so much about this problem that you can use this with before you get to calculus. So you enter this into whatever you're using. In this case, I was using Inspire. So I entered the function in, and that's my two graphs. Do you notice the symmetry? Does that make sense to you? The 294 degrees was the value of x that made the original cone the maximum, the volume. But if you let x be the other angle, the reflex angle, then it's going to be 360 degrees minus 66. So, and you've got beautiful symmetry. So this is another place where you could use this problem before calculus, because there's a line of symmetry here. You know, y equals x squared has a line of symmetry. Other functions have lines of symmetry. That's what you've got here. So you have a line of symmetry here. X equals 180 degrees. And you can ask students, why is it symmetric? So now what we need to do is to add these two functions together. And I know that this is much ado about nothing, because we already know that the answer is 180 degrees. You know, it's obvious that that's the angle, but let's just see what the graph looks like when you do this. What? I was actually just teasing you. The answer is not 180 degrees. This is a shocker. The answer is 240 degrees or 117 degrees. If this doesn't shock you, I don't know what does. Because there's like a compelling reason that says it should be 180 degrees. I mean, why should this cone count more than this cone? Symmetry tells you that it should be 180 degrees. And you know, have two sectors the same and make two cones the same. But it's not. If you make this angle 240 degrees or 117 degrees, and you make your two cones, that's when you get the biggest volume. Unbelievable. So this is a really cool result that you have here. I want to just finish here. This isn't about using calculus, but I did want to point out to you that Inspire does do calculus. So, and it's actually interesting to ask which equation would, you know, if you're going to do this by hand, which equation would you want to use? The first one or the second one? And in my calculus classes over the years, I always enjoyed showing this to students that you could replace the x divided by 360 by x and then do that. You know, differentiate, make it equal to 0, and then go back and figure out what the original value of x is. Because I would rather use the second one. But Inspire will do it. So this is what it looks like when you use when you do it by hand. That's what it looks like when you use Inspire. And this is what it looks like when you use Inspire with the sum of those functions that you have there. So that's called the computer algebra system on Inspire. So this PowerPoint file is going to have some extras in here at the end for you. You can take a look at this after. But I put together a Dropbox folder for you. So if you point your mobile device at this, you'll be directed to a website where I have this. You can have my PowerPoint file and you can work through it. I have a couple extra things in there as well. Or you can just go to tinyurl.com /CBC is calculus before calculus, RL, my initials, 2020, that's the year, and then 0725, July 25th. And so that will allow you to get some files. And I'll leave this Dropbox folder up for a while so that you can pull them out. So look, it's been a pleasure to be with you. I just wish I was with you. I've been to India several times. I'd love to come back. Maybe you'll have me come back sometime to one of your schools and come and be with all of you. But given COVID-19, this is kind of the best we can do right now, is to do it this way. I'm just wondering if there's any questions. If John or any others in the chat room, I haven't had a chance to be watching the chat room, but just with the remaining couple minutes, are there any questions that have come up in the chat room? I'm just trying to take a look here at Q&A. Doesn't seem to be any Q&A. Just looking for the chat. I'm not sure. Anyway, thank you very much. I hope there's been something here for you, that you'll be able to use with your students, and maybe some teaching ideas as well about how you can use this in your classroom. So I'll turn it back over to all of you.
Yeah,
John.
Yeah, one second. Thank you, Ron. Thank you so much. I quickly want to just run through the little troubleshooting for anyone who's keen on seeing what was going on. Just quickly, I'll just share that. If everyone can just see the screen, the problem was I used something called an angle. Just look at the angle. I mean, this is something that, gives me time to explore. Just look at the angle. The angle increases all the way to 180. And then watch what's happening. And then it's decreasing. Can you see that? To be honest, I've used TI. I've never noticed this feature before, that the angle is increasing up to 180 and then it starts decreasing. And it's because I used angle. And on the other hand, if I do the same problem using something called directed angle, and that's there on that same menu. If I go to geometry and the measurement, and there's another option called directed angle, and apparently that bit go when you turn it all around, that goes all the way through 360 degrees, and actually that is what will give us the graph. I mean, the feature, everything else that I laid out was as it is, but I guess that was the issue that we had, that we used angle and directed angle. Honestly, I don't know what the difference is, why there are those two features. Perhaps it's to be used in triangles where the angle is limited. I even went down to the settings to figure out whether there was something that was controlling. But I thought that was interesting that there are these two things called a directed angle and angle, and that is probably why we got the sine curve the way it was generating earlier.
The directed angle, it allows you in a geometrical diagram to be able to get two different angles.
Uh-huh.
So when you've got a triangle and you might want the exterior angle.
Okay.
So I think that's kind of where you'd use it. So that's the purpose of it.
And as opposed to angle, why are we going backwards from 180? From here it receives 180, then it goes kind of, it reverses almost back to, why is it limiting to 180?
I think because of what it's measuring, it's trying to measure, it's like an angle in a triangle. So it's trying to measure, it's kind of based on, the code is based on the angle in a triangle.
Right.
So, and not the exterior angle.
Mm-hmm, mm-hmm.
So probably could have been designed better,
Probably.
than that. But I'm glad you figured it out, John.
No, but thanks to, just a huge shout out to Jimmy, who's sitting there. Jimmy is a T3 instructor sitting in Singapore right now, and he was the one who set it up, and then let me also find out, and I was looking at it. So thanks to Jimmy and to Shraddha Naik, who was sitting there and suggesting about. And but more than anything, I personally want to thank you, Ron. Your lecture was very insightful. What I really, my biggest takeaway was, when should we use technology? I think that question, I think every teacher needs to ask before we even venture into that. So should we use, should we not use? And then students seeing that, when, like you used in your own activity, when there are too many cones, I mean, you have 10 cones, 20 cones, 30 cones, even 50 cones, yes, we can do all the reading. But then when we want to try and generalize, like we do it in our in the mathematical analysis and approaches curriculum, that when we need to generalize, you take one case, second case, third case, and then when you want to make a general conjecture, that's when you make use of technology and to try and get data.
John, if I could just add one thing, I noticed in the chat there's lots of comments there. One person wrote, this is very common in IB questions. Yeah, okay, it's common. What's not common is the way I did it. That's not common. I'm ripping this thing apart. The sum of the functions, the product of the functions, making the models, all of those details is not common. Okay, yeah, the problem's common, but not all of this depth, that's there. And the fundamental question that some teachers will have, or their thought is like, I got no time to do this. And maybe another time we could do a webinar about time, because one of the things to do this kind of thing, you really need to be nonlinear. You can't think of the curriculum as being this linear trip that you're going through, because if you do, you're never going to have time to do all of these different things you've seen. You're going to feel like you're on a treadmill. So the powerful thing here is that you really need to kind of think about your curriculum and its packaging pieces of the curriculum and interweaving them. And there's lots of research that shows that students learn much better when you weave together the curriculum and not, do them in pieces. John, are you still there?
I mean, I'm here, but Mrs. Naik, who wrote that, she was just explaining. It was not, I think she meant, yeah, you can read the comment that she's come up there.
Hassan, can you unmute Mrs. Shraddha?
Hi, Ron. Can you hear me?
I can.
Yes. So I I really found it interesting when you said, how you could encourage students to move on and not them struggle with a question or midway when they do not know how to find the answer to the function. But you just nudge them around and say, okay, you try and find it out. But in case you can't, here is a function, and then you can explore further. So that is what I meant in the long questions in the IB format papers. They generally do that. So they want students to keep on, they want to motivate students to think further and say, okay, if you haven't got an answer to this, here it is, now you can move on. So that's what I meant.
Yeah, that's beautiful. Yeah, well done.
Your question was really insightful, as John said. I loved the way that you explained. I've never thought of a question. We do these questions, cone questions, but I never ever thought of the way that you explained. And just you can start it at any grades. That was the beauty of the thing. You can introduce it in 9th, 10th, 11th, 12th, in different curricula. And so I'm really thankful for your, the way that you just helped us think along, in a very non-threatening, in a very encouraging manner. Thank you so much.
Oh, thank you. Yeah, and I'm so happy with how the IB does that.
Yes.
Like there's been a real trend to setting things up that way.
Right.
And
That's what I meant.
yeah, it's fantastic.
Ron,
yeah.
I met you at Exeter Phillips when you were the one of your workshop leaders, and I was teaching in Japan at the time, and your sessions there were almost fascinating, and I was really happy to know that you were taking a session for us today.
I'm so happy that you got to go to the Exeter conference. That's been a big part of my life. I've actually been a leader at that conference 31 years in a row, and long time. And I'm sad this year got canceled.
Yeah.
So I felt like I was missing something near the end of June. I hope we meet there again.
Yes, sure. And for everyone here on the session here, participants, I'd like to also say something about Ron. He had, in fact, please correct me, Ron, if I'm wrong. He had co-authored, or one or several of the series on numbers, the TV serial on numbers, and then one of your, there was one thing that you mentioned at the time that you had co-authored or one of those series. Can you?
Yeah, I mean, I was just part of the team, but Numbers was a television show on CBS, and it was quite popular. And there was a company called Words and Numbers that brought together some math teachers to create math questions for every show. And it was a wonderful opportunity. I enjoyed working with people, collaborating with others. I was just part of the team,
Yeah.
But what happened is we would get a little piece of the script ahead of the show. CBS did not want us to have very much information. So it was a little bit. And then we created math activities for students.
Yeah.
And it was really hard because sometimes, the questions we prepared had nothing to do with the show, because we didn't know the whole show.
Yeah.
And other times, it tied in closely. So, but it was nice doing that. It was a nice project to work on and to be part of. Thank you.
Thank you.
Are there any other questions from any of the participants? I'm okay time-wise here. Any questions at all? Well, maybe just one final comment. That business about being linear. It's interesting, in our Ontario curriculum here in Canada, teachers are actually expected, they're told, to weave together the content. I'm not going to suggest to you that all teachers do it that way. They don't. Change takes a long time. But there is an expectation that that's how we teach. Because, you know, and I think the IB is moving in that direction as well. You know, if students learn a topic in isolation to other topics, they're not going to retain it as well. So actually blending together topics, maybe not all the time. I think balance is important. But that's something that we're attempting to do, you know, here in Ontario, is weaving together
Your job is to
the
make
content.
wonderful chaya for me and my son.
I think somebody's speaking. No. So thank you, Ron and John, for this informative and interactive session. And thank you all for joining the webinar. If you have any query regarding the product, you can contact us. Let me show you the details. So you can contact us on the given details. So once again, thank you, Mr. Ron. Thank you, Mr. John.
You're welcome. And
It
you
was a
know,
wonderful session. Yeah.
thank you. With
Thank you.
COVID-19, I hope that all of you will be okay. Things are getting better in Canada. So our numbers are going down. Things are starting to open up. So we're feeling, you know, fairly good, but we're pretty worried about a second wave. So we're all wearing masks outside and being careful. I've been following what's going on in India as well, and I just hope for all of you that you're safe, that you know you're not shattered. There are many people around the world that are losing work. It's just a mess. But I'm hoping that all of you will be okay.
Thank you so much. Thank you so much, Ron. And we look forward to more collaboration with you. Thank you, Ron. You know, thank you so much for your time and your wonderful insight that you shared with all of us.
Thank you.
Texas.
Thank you all.